Hey guys, it's Miss Fearing here. Welcome to Unit 7, Notes 1. We're going to go ahead and we're going to start a new unit on probability. So today we're going to go ahead and we're going to look at the fundamental counting principle. So here's our first situation here. We're in a cafeteria and we have several options for a sandwich that we want to buy. You can choose either white or wheat bread. Then you get to choose turkey, ham, or roast beef. And then you get to choose cheddar, American, or provolone cheese. So we want to construct what we call a tree diagram to represent the number of different possibilities from our sandwich, assuming that you can only select one from each category. So our first option to pick from is going to be our bread. We can either have white bread or we can have the wheat bread. Then from there, we're going to have branches that come off of here and we're going to choose our meat that we want. So there's 3 different types of meat we could have. We could have our turkey, our ham, or our roast beef. And we have the same 3 options if we chose the wheat bread. Now from each of these options, we have 3 more branches where we get to choose our cheese. So we can have cheddar, American, or provolone. So cheddar, American, or provolone. And from each of these, cheddar, American, or provolone, cheddar, American, provolone. And then same for our wheat sandwiches, cheddar, American, provolone, cheddar, American, provolone, and cheddar, American, provolone. So basically what this is showing is that I can have a a turkey sandwich on white with cheddar cheese, or I can have a turkey sandwich on white with American cheese, or I can have a turkey sandwich on white with provolone cheese. So that's 3 options I have right there. So basically what it's asking is how many different possibilities we have for sandwiches. We can find that based off of this bottom row down here. This tells me all of my different sandwiches I could possibly have then. So in this situation, I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18 different possibilities of ways that I can make a sandwich. So 18 ways. So it's going to get kind of big, though, if we look at different situations. We don't always want to write out all of these different possibilities that we have, and we don't always want to create these tree diagrams. So we're going to look at something that's going to help us do this a little faster. It's called the fundamental counting principle. So basically what this says is if you have one event that can occur m ways, and then another event that can occur n ways, to find the total number of possible ways, all we do is we take those and we multiply them together. So we would do m times n. So let's look at this example here. We have Farmington High School soccer team. They have orange, white, and black jerseys. They then have orange or black pants, and then black or white shoes. We want to use the fundamental counting principle to determine the number of uniforms they can wear. So the first option they get to pick is their jersey. So they get to decide what color jersey they want to buy or they want to wear. And they have how many different options that we determine. They have orange, they have white, and they have black. So they have 3 different options for jerseys. Then they get to pick their pants. And options for pants, they have orange or black. So they have 2 options there. And then they get to pick their shoes. What color shoes they want to wear. They have black or white shoes. So they have 2 different shoes to pick from for that. So what the fundamental counting principle tells us is we just multiply these numbers together to figure out a total number of ways. So we'd have 3 times 2 is 6 times 2 is 12. So there is 12 different uniforms or ways that they can dress themselves for these games. So now example number 3 here, we're going to go ahead and we're going to pick a new car out for our 16th birthday. Woohoo! We have a choice between 7 different exterior colors, 8 different interior colors, and then 4 fabric choices. So we want to figure out how many different possibilities of color and fabric choices we have for our car here. So that we get to pick 3 different things. The first thing we get to pick is the exterior color. So exterior color, we have 7 options for that. So we have 7 options. Then we get to pick the interior. So for the interior, we have 8 options. And then we get to pick the fabric. And for our fabric, we have 4 different options. So we're going to multiply all of these guys together like the fundamental counting principle tells us to do. And we would come up with 224 different choices of car for our 16th birthday. So here's our next example. We're going to look at some counting arrangements. So we have the student council that has a president, a vice president, a treasurer, and a secretary. For the school assembly, they're all required to sit up on a row and stage. So we want to figure out how many different ways they can arrange themselves. So I'm going to kind of think of my stage, and on my stage I have 4 different seats. And when my members walk up, I have 4 different people that get to choose which one is going to sit in the first spot. So I have 4 different options for the first spot. Once one person sits there, we can't put them in a different spot. So then the next spot, we only have 3 options of people to sit there, and then 2 and 1. The fundamental counting principle then tells us we just multiply these together. So there are 24 ways that these students can arrange themselves on stage. And this example is actually going to lead us into our next thing here. It's called a factorial. So you guys are going to read this as N exclamation point. And this isn't us screaming N all the time. When you see that, we read that in math as a factorial. So this exclamation point is called a factorial. So basically what that means, it is the product. Remember, product just means multiplication. So we multiply all of the positive integers beginning with the N, counting backwards all the way down to 1. So if we were finding the value of 6 factorial, we would begin with 6 and multiply all the way down to 1. So we'd have 5 times 4 times 3 times 2 times 1. If you plug all of that into your calculator, you would get 720. So for the next one, if we're finding 8 factorial, we would start with n, so we'd start with 8, and multiply backwards all of our numbers all the way down to 1. So 7 times 6 times 5 times 4 times 3 times 2 times 1. Plug that into your calculator, and you get 40,320. So let's look at an example here. We have Mackenzie setting up a display of our 10 most popular video games from the previous week. If she places the games side by side on a shelf, how many different ways can she arrange them? So we want to kind of think about like our 4 stools up on stage there when we're talking about our last example. And this time we have 10 different slots on our shelf that we need to fill. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So I want to think, how many options do I have for the first one? Well, I have 10 popular video games, so I have 10 options for the first one. Once I put one down, I only have 9 then for the second one, 8 for the third, 7, 6, 5, 4, 3, 2, 1. Remember, we're going to multiply these guys together. This is kind of like a fundamental counting principle. This then is basically saying 10 factorial, because we started with 10 and we multiplied counting backwards all the way down to 1. There are so many ways that we can arrange these 10 different videos or 10 different video games. When you plug all that into your calculator, you're going to get 3,628,800 different ways that we can arrange these video games. So that's a lot of different ways that we can arrange them. So let's go ahead and look at our last example here. We have Zach and Brody that are going to amusement park. They can't decide which order to ride the 12 roller coasters in the park. How many different orders can they ride all of the roller coasters if they ride each one only once? So we have 12 different rides that we want to do. So I have 12 different spaces. 3, 4, 5, 6, 7, 8, 9, 10. Ooh, I'm running out of space. 11, and we'll put one over the picture, 12. So I have 12 different roller coasters I want to ride. On the first one I get to pick from, I have 12 to pick from for that first. I'm going to ride each of them only once. So then if I rolled 1, I now only have 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. Remember, we want to multiply these together. So basically for this first one here, I have a 12 factorial situation going on. Plug all that in. There are so many ways we can ride these rides. We have 479,001,600 different orders or ways that we can ride these 12 different roller coasters. So now, if they only have time to ride 8 of the roller coasters, how many different ways can they do this? So now, instead of picking 12 different roller coasters to ride, I'm only going to pick 8. 3, 4, 5, 6, 7, 8. But when I think about the first one I want to ride, I still have 12 of them to choose from because there are 12 total up here. So now I'm still going to have 9, 8, 7, 6, 5, and we're going to multiply these together. This one's different from the first one then because we cut it off. We didn't have these last 4. We stopped right here. So this is a little bit different than what we did before. It's not really it's not a factorial. We're going back to our fundamental counting principle here. When you plug all that in, we still have a lot of different ways that we can ride just 8 of the 12 roller coasters. We have 958,400 different ways. So now it is your turn to go ahead and try some practice. If you have any questions, please come chat with me.